Good day viewers. Well, I've had a bit of an update in my Model M keyboard. I actually contacted the seller and he's actually sending me a replacement question mark keycap. Now apparently that keycap was there when he sent it off, so when that keyboard got opened up in customs lost that keycap. So it's been lost when it came in, customs opened it, and that's where the keycap got lost. So he's sending me another keycap replacement one free of charge, which is good. So I've got that all nice and complete. I also had problems where half the letters weren't working. I plugged it into another machine, on a USB converter and all that, and a couple other computers. The keyboard's fine. It's just on that one computer it was working and it didn't work, and I found the PS2 socket had a bit of dust and stuff in it. So I cleaned that out and it seems to be working alright now. So yeah, it's good. It's actually a nice keyboard. Fucking, I wonder if high current can burn that out. That's a good way to do it. Let's see if of course it smoke. If I put this current for this resistor, I don't know if this will be enough to smoke it. It's not already open circuit. Let's see if this makes it smoke. Let's see if it smokes. I think it's open circuit. Yeah, it's open circuit. No more smoke in that one. No. No smoke. It's gone. If I can pulse this coil here. Nothing. Nothing. Oh, okay. Not doing anything. Let's burn the tracer out then. No. Can't get this to burn out. This thing is that buggered, is it? Oh, let's set this up properly. Burn out some small SMDs. No way. Can't get them to burn out. Interesting. There you go. Pop. A screwdriver to probe it with, an old bit of metal or something like that similar to probe it with would be a better way to do it. And I set the tripod up. Right. That's better. Let's get a little crap bit of metal, something I don't really like. Bit of copper, that'll do. I use a screwdriver, I'm going to end up ruining it. Well, we've got current, that's for sure. Gotta get some poppage, that's what I need. Reconnect that bit. And that little device there, 47RO. Interesting. It's a capacitor, I think. That's weird. Didn't even get hot. The coil don't work. Yeah, that one. Pop that device. So a couple of capacitors and 2 transistors, and that's it. That's all it is on this thing. And that air popped. Let's see what this transformer does. Won't do anything with DC, but let's see what burns out at least. I've got to put AC through it to get any voltage out of it. Pretty sure it's got an iron core in there. But if I took this all out and drilled out that separator, this would probably make a good toroid for flyback driver, ZVS. Soldered on pretty hard too, that one. What else could I burn out? Could be more now I can burn out surely. There. Cross that one. That wire back on here. No, that's disappointing. This coil don't even do anything. Coil might have failed. Alright, turn that off. Unplug safety first. I'm going to crack this coil apart. See if that's actually burnt out. In there. So there's a little adjuster on the bottom of this which went under there. There was a hole there which goes to an adjustment on here, and that's the adjustment there that you can access from the outside of the RCD. You pop out a little plug, you can access this tiny little screw, and I think that's to calibrate this thing for exactly 30 milliamps so they can trip at. It's a calibration screw. If I can turn that, I think I can. Yeah, I just turned it a little bit. But you turn that screw, you get an RCD tester, you can calibrate this thing so it trips at exactly 30 milliamps. And that just adjusts a little screw, a spring. There it is. Normally accessed from the outside of the case. Just pop out a little plug at the bottom and you can access that screw to adjust this breaker. Break that off, I don't break it anymore. There we go, slip the bastard out. That's how you do it. I mean, it's never going to work again. Some sort of clip. V9-1 E74244. Some sort of part number. Pop that bottom bit off. And that's that pin, that coil pops out. That's kind of cool, and that little tiny coil. Put a little winding around that on a ferrite core. Wonder what voltage I'll get out of this thing. Quite a nice little coil on there. That's all that screw adjusts, this bit here. There's a magnet in there and that will pop out and trip the breaker. That's the actual part there, the RCD itself. That's powered by that transformer. And when there's an imbalance in the load, this will be triggered and that pops up, trips the breaker, and it's reset. The magnet resets it. Normally on, bang, trips. Pops up, trips the breaker. The magnet's there you go, it's a neodymium magnet there. Very cool how this is made. You can see how these things work. Take that out. And there's a neodymium. There you go. I could whack a tiny ferrite core in that. There you are. Nice little magnet. And a handy little coil. Which the leads of the coil, I've ripped them completely out. There they are there. The two ends of the coil are here. You can't see them, but they're so damn thin. Hair thin wire. There it is there. There was two of those I just ripped out of the case. Didn't do anything when I put the voltage across it. So it's obviously a 240 volt coil, that one. So if I were to put a tiny ferrite around that and ZVS drive it, that coil will give me 240 volts at most likely 30 milliamps of current. there we are, that's what was inside the brains, so to speak, of the RCD itself. That's the switch contacts, you've already seen that. Anyway, that'll be enough for now. Thanks for watching.